Linear functions. Pause and complete your lesson opener. Plot each point and sketch a line. Check your lines. Slope measures the steepness of each line. So if I consider line A, I could find the slope by looking for the vertical change, which is up 5, over the horizontal change over 3. We always work from left to right when we're computing slope.
Do we always have to have a graph of a line to compute slope? No. Let's take a look at that vertical change 5. Well, where did that come from? Take a look at the y-coordinates. We had a y-coordinate of 7 and a y-coordinate of 2. 7 minus 2, 5. Now let's take a look at the horizontal change. We had a horizontal change of 3. Well, once again, take a look at those x-coordinates. 4 minus 1, 3. The slope formula is y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Remember, it's best to label the points and always use the same point first. When graphing and using slope, we consider slope as rise over run. Now the rise could be positive or negative. When we look at our second line and we count that out, we have to go down 8 units and then over 4 units. So it ends up having a slope of -2. For slope, we most often use the variable m to describe it. It is vertical change divided by horizontal change, or delta y divided by delta x. That little triangle is delta. And last, when given 2 points, we use that formula y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1.
Now let's practice calculating the slope between 2 points. Remember, we always want to start by labeling our points first. X sub 1, y sub 1, x sub 2, y sub 2. Slope formula, m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Write your formula down. The more you write it, the more you're going to remember it. Y sub 2 is 1. Continue plugging in the values for y sub 1, x sub 2, and x sub 1. Our numerator is 1 minus 7, so -6, and our denominator is 8 minus 5, so +3. -6 divided by 3 is -2. Our slope is -2. Look at the next one. What's the first thing you're going to do? Label your points. Go label your points and plug into your slope formula right now. Check it out. I plugged in my points. What do you notice about the denominator? I have a -4. Well, 2 negatives make a positive, so let's make that +4. Numerator, -5. Denominator, -2 plus 4, +2. -5 halves is my slope. Finish the last example and come back and check. -7 divided by 0. Oh, Ms. Peart, what do you think they're gonna say that is? 0. No! Oh, it's not 0!
It's time to tell them the math commandment.
The math commandment, go!
Thou shalt not
Divide by 0!
One more time.
Thou shalt not divide by 0! We can't divide by 0 in math, so we say that our slope in this case is undefined. Wonder what an undefined slope looks like. Let's plot these 2 points and find out. Would you look at that? It's a vertical line, so any vertical line has an undefined slope. Later we'll learn that this is also not a function because it doesn't pass the vertical line test. Since we're having these weird slopes pop in, let's talk about what kind of slopes we could have. A positive, negative, 0 slope, or undefined slope. This first graph, do you think it's a positive, negative, or 0 slope? Well, I have a trick to always remember. On the leftmost part of the graph, I draw a car on the line. I try to imagine myself in that car, and if I slammed on the gas, would my car jet up a hill or go down the hill? I'd head down a hill. So this means I have a negative slope. The next one, we already know. It's a vertical line, so undefined slope. Do you think you know how to write an equation for a vertical line? Well, everywhere on my graph, the value for x is 3. So my equation for a line is x equals 3. Now the next graph is a horizontal line. This has a 0 slope because we rise 0 as we run across. Everywhere on my graph, my y value is -3. So the equation for this line would be y equals -3. Last graph, let's use that car trick. Car, leftmost part of the graph. Slam on the gas. Where are you headed? Up a hill. So this has a positive slope.
Now let's talk about how to write the equation of a line. Well, we already know the slope formula. So let's not learn something brand new. Let's just take that slope formula and solve it for y minus y sub 1. In order to do that, what do we need to do? Well, y minus y sub 1 is being divided by x minus x sub 1. Gee, I think I need to hug it out, and I need to move that x minus x sub 1 to the other side of the equal sign. So let's undo division. Multiply both sides by x minus x sub 1. Hug it out. Now, as we start to clean this up, I'm going to use commutative property of multiplication and bring the m in front. So now I have m parentheses x minus x sub 1 equals y minus y sub 1. And there you go. We have an equation of a line in point-slope form. But it's probably best if we go ahead and write that y minus y sub 1 in front using symmetric property. This equation is known as point-slope form because all we need is a point. Notice we have our x sub 1 and our y sub 1, and slope, the m.
Let's practice writing some equations in point-slope form. Here we're given a slope and a point. Always label your points first. X sub 1, y sub 1. Done. Now we can use our point-slope form as almost a skeleton. Everywhere I highlighted, I'm going to leave blank. So I'm going to write y minus blank equals blank times x minus blank. Now, all I have to do, since I have a point and a slope, is fill in the blanks. Okay, first blank, what's supposed to go there? Y sub 1. So, 5. Next blank, that's where m goes. That's my slope, 3. Third blank, x sub 1, 2. I just wrote an equation of a line. Y minus 5 equals 3 times x minus 2. Let's write the equation for b. Remember, label your point first and draw out your skeleton. Y minus 5 equals negative 4 times x minus negative 1. Can't leave that double negative. Make sure you write x plus 1. Looking at c, this time I'm given the equation in point-slope form. Do you think you could identify the slope and the point? Work backwards. See if you can do it. Check your work. The slope is negative 2/3, but did you get the point right? It's negative 4, 2. That negative 4 is so important. Why is it negative? Because in my slope-intercept form, it's x minus x1. And if mine changed to plus 4, then I had to have a double negative there to get that positive. It's almost like when we did transformations, inside opposite, right? So we could hug out that left side of our equation as well, the y minus 2, inside opposite. So when we pulled it out to our point, it became positive 2.
Let's go back to A and graph. We have the point 2, 5. Well, let's think about that again. 2 is our x coordinate. So from the origin, go to the right 2, pause, and then count up 5. Now from the point 2, 5, we're going to use slope and plot another point. Rise over run for slope. Right now our slope is an integer. We're going to write it like a fraction. So 3 divided by 1. The top number, the numerator, is the rise. It's positive. So we'll rise 3 units, and then the denominator is run. It's positive, so we'll run right 1 unit. There's our slope triangle. Now plot your second point. With 2 points, we have our line. On B, we have the point negative 1, 5. So let's plot that. To the left 1 unit, pause, and up 5 units. Now using slope, it's negative 4, so negative 4 divided by 1. Let's assign the negative to the numerator. So that means our rise is negative. We're going to count down 4 units, but the denominator is still positive, so we're still going right 1 unit. Graph C. How'd you do? Was your second point the x-intercept of negative 1, 0?
For these last two, we need to still write an equation of a line, but now we're given 2 points. So what am I missing? In my skeleton, I need a point and I need the slope. So I have to find the slope first. Do you remember that slope formula? Try to write it down really quick without turning your notes over. Okay, to help us continue being successful, we should label those points and plug into our slope formula. Looks like my slope is 7/5, so I can add that straight into my skeleton. Then I gotta pick a point. I have 2 points. I have more than I need. You just need to choose one of them. I'm just gonna choose the one that's labeled x1, y1 and cross out the other one so I'm not tempted to use it again. So plug in 0 for y1 and -5 for x1. Double negatives plus 5. Now it's your turn to use all the skills you've learned in this lesson. Take your time, be careful. Find slope, then use point slope form to write your equation. Take a moment to check your lines. Remember, there's 2 possible answers here, but they're equivalent. I smarted today.